This is primarily by Shu and I. The actual proposal text was written by Shu. And this is something that was, this particular proposal has several motivations, but first on history, it's extracted from the stabilized proposal. So to just do a very, very quick recap, stabilize was proposing new integrity traits, and it broke it down into these 5 orthogonal integrity traits to consider. And in the last meeting when we talked about stabilize, we explained our hopes and dreams, which is that the fixed integrity trait, which is the one that we're talking about today, be bundled into the existing non-extensible integrity trait, so that it would not be a new integrity trait, it would just be new behavior associated with the existing non-extensible trait. And what the fixed integrity trait is about, or what this new behavior is about, is illustrated by the following code, the contrast between the subclass on the left and the subclass on the right. So in this case, just as a expository example, they both inherit from the same superclass named frozen base, and the superclass constructor, for whatever reason, just freezes this. And on the left, the add property subclass adds a public named property to this, but it's doing it, of course, after the super returns. Before super returns, there is no this that's in scope. And once super returns, this will, as you expect, throw a type error. On the right, we have what is essentially the same code, except that instead of adding a public property, we're adding a private field. And today, this does not throw. This actually adds the private field, even though the object is already frozen, and because it's already frozen, it's already non-extensible. The reason we get the type error here is not because it's frozen per se, but specifically because it's non-extensible. And we think that this difference, first of all, is counterintuitive. That's one motivation. So what we're proposing is that non-extensible that the meaning of it be extended in a way that we claim is already intuitive. It is the thing that would be least surprise, such that an attempt to add a private property to an object that's already non-extensible would also throw a type error. Although that's a nice motivation, it probably wouldn't have motivated us doing something as dangerous as this, dangerous in the sense that what we're proposing is technically non-upwards compatible, which we'll come back to. One motivation of this is that the struct implementation, the struct proposal, which is proceeding as a separate proposal, a lot of the rationale for it is that structs are essentially better classes, and better in particular in ways that enable them to have a high-speed implementation. And the problem with the current semantics is that this extensibility of private properties combined with return override can be composed to force the engine to add a private field to an already constructed struct instance. And given the way private fields are implemented by, as far as I know, all the high-speed engines, in order to, they would then have a choice, which is give up on structs necessarily having a fixed shape, which would hurt the performance promise, or have a completely different path through the engine for adding private fields to structs that are completely different than they are for adding private fields to other objects, neither of which we like. So with this proposal, this attempt to change the shape of structs, which is the only thing right now in the language that would imply that structs shape can change at runtime, this would instead throw a type error, and as far as we can tell, that means that structs can faithfully to the spec have a fixed shape high-speed implementation. The other motivation is mostly hinted at by this piece of code, which is that the ability to add private properties via return override to existing objects essentially gives the language something that's very much like a weak map, but makes it accessible by syntax, and therefore also fairly global. So over here we've got, when we're trying to reason about communications channels, this weak map reachable by syntax is a problem, because you might freeze the class and freeze the prototypes and all the methods, so it all looks like there's no hidden state in here. And then you take two other objects that you know not to have hidden state for the normal meaning of state, and thereby not represent a communications channel. And then one party might use this hidden map functionality to create a mutation of surprising state that the other party can sense. And this hints at larger problems with virtualization that I can get into if there's questions. But let's just say that there's several different motivations that are quite crucial for both parties that all have the same simple solution. And the solution is indeed quite simple. It is so simple that Shu initially raised the possibility of doing this as just a needs consensus PR, which I think which I will agree is reasonable. I prefer than anything that has semantic observable effect, especially when there's a danger of incompatibility. Just go through the discipline of a proposal, but still one that we hope can advance fairly quickly. So these two changes is the entirety of the proposal. These are the two operations in the spec that can cause a private field to be added to an object. And we're just proposing that both of these do a precondition check, an input validation check, to verify that the object is extensible and otherwise throw a type error. Now, with regard to the potential danger of incompatibility, would this break the web? Google has generously already deployed usage counters to find out. And the bad news is that over time, this has still been growing monotonically, or been growing. It has not been asymptoting, but the numbers here are like 0.000015%. So they're tiny, and they're a little bit more, by the way, with desktop than mobile. I think the 0% here showing on both is just rounding errors in the display. But these are the 6 websites, all in Germany, where a problem was detected. And for all these 6 sites, there's only 2 cases. One case is this weird piece of code that we don't quite know why it's the class is named underbar. So over here, it's looping through the fields of underbar in order to initialize a private field of the underbar. Enumerating the public enumerable fields of underbar in order to add a private field of underbar. But during this enumeration, it's freezing underbar itself So the disturbing thing about the proposal is that this code, for whatever weird reason it might exist, is currently correct. And the price of accepting this proposal is that this code would start misbehaving despite the fact that today this is correct code. And likewise with the other case, which is perhaps more understandable, which resembles our first counterexample, which is a superclass constructor that freezes this and then adds private properties in the subclass. So given that these are in both of these cases we would be breaking correct code which exists out there on this very small portion of the web, it is conceivable that browsers would not be willing to go forward on this. Google, as a co-sponsor of this proposal, looking at these numbers, have decided that they themselves are willing to go forward. It's also conceivable that non-browser implementations might object to the non-upwards compatible change as well. So that's the question we have for the committee today. And what we would like to ask for is first stage one, but since this was something that was reasonable as a needs consensus PR, we would, if we give us stage one, we're going to ask for more, which we may or may not get. Oops, sorry. So first of all, may we have stage one? This is the actual official statement of stage one.